All right, we got quite a few to work through on these, so let's go ahead and get started. So just like on the last ones, we are still substituting, but this is medium substitution. So what's happening here is they are not giving me one of the values of x or y. They're not telling me that x equals 4 or that y equals 7, okay? However, they are giving me an equation where there's a variable by itself. So you'll notice on this bottom equation right here, y is already on a side by itself, and that helps us a lot, okay? So what we're going to do is we're going to use that to our advantage, okay? So we're still going to substitute the exact same way we did last time, okay? I'm going to rewrite my equation, the top equation, the one that doesn't have a variable by itself, okay? 2x plus 7y equals 39, all right? And again, the problem is I've got both x and y here. And the reason I'm using that top one is because you see how x and y are on the same side with each other. You know, we don't have x by itself on this. We don't have y by itself on this one. So this is the one that I'm starting with right here, okay? And so the other one, it does have y by itself, but it doesn't say that y just equals 3 or that y just equals 1. It says y equals 3x minus 1. Okay, and I'm still going to substitute that in, all right? And I'm going to show y'all what's going to happen here. Now, it does say y equals, so just like we did on those easy substitutions, I'm going to take this line and I'm going to draw it to the y, okay? Again, I'm not plugging this in for 7y. I'm just plugging it in for y. So I'm going to rewrite everything else, okay? So I've got 2x plus 7, but where I see y, I am plugging in what I have circled over here. Okay, I'm plugging in what we know y equals. So I'm going to change y to 3x minus 1. Okay, and then equals 39. So notice the only thing that changed is y changed to 3x minus 1. All right, so I want you to notice now, if you look, there was an x and a y, two different variables. Now there's an x and an x. There's no more y in this problem anymore, right? That's the whole point. We need to get it to just where it's one variable and not two different variables, okay? So your warm-up was very similar to this. So I'm just going to go through and start working this. You should be pretty decent at solving equations like this. If not, this would be a good point maybe to pause the video and to try and solve the rest of this yourself and then unpause and see how you did. Okay, I'm going to keep going though. Draw my line. Got to get rid of the parentheses first. So I bring down my 2x. Again, this is a positive 7 times 3x is positive 21x. Positive 7 times negative 1 is negative 7 equals 39. Okay, I've got like terms. 2x plus 21x is 23x. Bring down the minus 7 equals 39. Okay, no more like terms, so I start to get x by itself. Get rid of the constant first, the number being added or subtracted. So to get rid of a minus 7, I add 7 to both sides. 23x equals 39 plus 7 makes 46. X still is not by itself. It's being multiplied by 23. I need to divide by 23. 46 divided by 23 is 2. All right, so here's where it differs, okay? We are not done. We have only found half of our answer. Remember, our answer is made up of both x and y. We just found the x, right? So I can go ahead and plug in that answer for x up here, but I still got to figure out what y is, because remember, on these problems, they don't give us one of those values. So I want you to go back and notice over here, we're given that y equals 3x minus 1, right? The only thing keeping me from knowing what y is that I didn't know what x was, right? If I knew what x was, could plug it in, and there's y. Well, guess what? We now know that x is 2. So I'm going to take this value of x right here, and I'm going to plug it in and substitute it for x in the other equation. Y'all see how this is making kind of a circle, right? And we get our answer, and it comes back around, right? It makes a full circle. So I'm going to plug that answer in right for there. Okay, so I've got y equals 3 times, not x anymore. We now know x is 2. So I'm going to replace x with that 2 minus 1. Okay, again, 2 is the number that got replaced there. Okay, notice y is by itself already, right? I'm not really having to solve for this. I just need to simplify what's above there using PEMDAS. And so to simplify, okay, we do multiplication first. 3 times 2 is 6. Bring down the minus 1. And 6 minus 1 is 5. That is the easiest part of this substitution. If you can handle this hard part over here, then the last part is super simple. So again, not done. I need to take that answer, y equals 5, plug it in up here, and this is my answer. This is what I would type in on my formative. Remember, you got to put the parentheses, 2, comma, 5, close parentheses, no spaces. Don't forget the parentheses or the comma, okay? It will show red. It will count it wrong if you do not put all of that information there, okay? All right, let's go ahead and do another problem. Okay, so on this next one, same situation, but notice here, x is by itself, right? It's not equal to a whole number. It's equal to an expression. I'm going to do the exact same thing. So I've got negative 3x plus 4y equals 78. Okay, again, this time I'm going to circle what x equals. Okay, again, I'm using the equation that has the variable on a side by itself. And I'm going to draw a line to the x because, again, it was x that's by itself this time, not the y. All right, and I'm going to plug in just like I did earlier. Negative 3 stays, parentheses, but now I'm replacing x with that negative 6y minus 4. And then I bring everything down. A lot of people will accidentally forget that plus 4y right there. Make sure you don't forget that. Plus 4y equals 78. Okay, again, I'm going to point out we originally had an x and a y. Now I just have a y and a y. Went from having 2 different variables to 1 variable. That's how I know I did this correctly. All right, again, good point for you to pause, see if you can solve this, and then unpause, see if you got it right. I'm going to keep going. Okay, so parentheses, draw my line first, now parentheses. Negative 3 times negative 6y is 18y. Negative 3 times negative 4 is positive 12. Bring down the plus 4y equals 78. Combine like terms, 18y plus 4y is 22y. Bring down that plus 12. There are no more like terms here, so I can start solving. So we get rid of the constant first. To get rid of a plus 12, we minus 12. What you do to one side, do the other. Cross those out. 22y equals 78 minus 12. So 78 minus 10 is 68, minus 2 is 66. Y still isn't by itself. It's being multiplied by 22. So we divide by 22. 66 divided by 22 is 3. So again, not done. Okay, our answer is a point made up of an x and y. I just found half of my answer. And this time I found the y, right? Y is 3, so I'm plugging that 3 in the y spot up here, okay? I'm going to take what y equals, right, which is 3, And I'm going to make full circle, plug it into the y in the beginning, that first thing I circled up there. Okay, so I've got x equals -6 times, again, this is no longer y, but what we found that y was, which is 3. And then -4. X is already by itself. All I have to do is simplify using PEMDAS, multiply first. -6 times 3 is -18. Bring down the -4. And then -18 minus 4 is -22. And that is the second half of my answer that I now plug in up here. So my answer is -22, comma 3. Again, don't forget the parentheses, don't forget the comma. Okay? All right, let's do 2 more problems. These look a little bit different. Okay? What I want you to notice on these 2 is that they both have y by themselves. Okay? It makes it look more complicated, but it's actually easier. Okay? So since they both equal y, all right, wouldn't you agree that y equals itself y, right? Y equals y. Y is y. If y is 4, the other y is 4, right? Well, in this case, y is -x plus 8, and y is also 3x minus 4. We don't know what x is necessarily, but whatever it is, it makes those 2 y's become the same number. Okay, so what I'm going to do, since I know y equals y, right, I'm going to take this and plug it in here. And I'm going to take this and plug it in here. All right, and that's going to end up making -x plus 8 equals 3x minus 4. Okay, when they both are solved for y, you just set the other two sides equal to each other. That's all you do. Okay, we just set the other two sides equal. Notice the y's are gone. There is no more y's. It's just x's now, right? Okay, so now I'm going to solve. Draw my line. Notice I've got x's on both sides here. What I want to do is I want to get all my x's on one side and all my constants or whole numbers on the other side. I personally like to get all my x's on the left side. So I notice -x is already on the left, right? So I'm going to leave it there. But 3x is on the right. If I want to move 3x over to the other side, I have to do the opposite to it. When the opposite of positive 3x is minus 3x. So I'm going to have minus 3x over here, right? Equals. Now, -4 is already on the right, okay? But I want that 8 to be on the right. The 8 is on the left. I need that positive 8 to move to the left, to the right side. So to get rid of a positive 8, I subtract 8. And so now, and those would cross out, right? So now I can see that I've got all my x's on the left side and all my constants or whole numbers on the right side. Okay, so that puts my like terms together, right? So now I can combine those. Remember, -x is just -1x. So I have -1x minus 3x. That makes -4x equals, and then I've got -4 minus 8, which is -12. Okay, x still isn't by itself. It's being multiplied by -4. The opposite of multiplying by -4 is dividing by -4. And what you do to one side, you do to the other. And x equals -12 divided by -4, which is +3. But like I've been telling y'all from the beginning, our answer is a point made up of two numbers, an x and a y. We just found half of that answer, the x. So I'm putting 3 in the x spot. Still got to figure out what y is. Now, on those other problems we did we needed to plug it into a specific one. It doesn't matter here. Since they both have y by themselves, we can plug this x into any equation we want, either one of them. Okay, I'm just going to go ahead and take it and plug it into that bottom one. Because again, it doesn't really matter. That's just the one I see. So I'm going to have y equals 3 times x, which we're letting x be, or x is, we're not letting it be, but x is 3. And I just do the math. 3 times 3 is 9. Bring down the minus 4. And 9 minus 4 is 5. Okay, again, the answer is not 5. That's the other half of our answer. So I take that 5 and I plug it in up here. And the answer is 3, 5. All right, we got one more problem like this. And then y'all are going to try some on your own. Okay, once again, both y's are by themselves. So once again, we know that y equals itself y. So I'm going to take the top y and plug it into that side, the bottom y, and plug it into that side, right? So once I do that and I take them and plug them in, I'm replacing the first y with 2x minus 18 equals the second y, negative 3x plus 7. Okay? And we solve for x, because once again, all the y's are gone. There's nothing but x's left. I would encourage you to pause here, see if you can solve this by yourself and get your x, and then even see if you can try and finish it up and figure out what y is after that. Okay? If not, you get stuck, press play, and keep going. All right, so I want to get my x's to the same side. So 2x is already over here. I want to move that negative 3x over. So to move over a negative 3x, I would add 3x. Okay. 7 is already on the right side. I want to move that minus 18 over. So I would add 18. Okay. All my like terms are together. 2x plus 3x is 5x. 7 plus 18 is 25. 5 is being multiplied by x, so we divide by x on both sides, or divide by 5 on both sides, my bad. And 25 divided by 5 is 5. Once again, I have only found half of my answer. We have just found the x. We still need to figure out what y is. So I'm going to take this x, and again, I'm just going to plug it into the bottom. It does not matter which one you plug it into. You can plug it into the top if you wanted to. I'm just going to plug it into the bottom. Okay? It doesn't matter which one you plug it into. You're going to get the same answer no matter what. All right? You can test that if you would like, if you want to, and you can and you can prove that that is what happens. Y equals negative 3 times x plus 7, but I'm replacing x with 5 because we found that x was 5. Okay. All I got to do is simplify. Negative 3 times 5 is negative 15 plus 7. And negative 15 plus 7, signs are different, so we subtract. 15 minus 7 is 8. And we take the sign of the bigger number, negative. Again, the answer is not negative 8. That's just the second half of our answer. I plug that back in up here, and my answer is 5, the point 5 comma negative 8. Okay, again, those answers are where the two lines are intersecting, right? It's where those two lines are crossing. That's why we're finding points here as our answers. The answer is not just x, it's not just y, it's a point. Okay, so it all goes back to when we were doing, earlier this week when we were graphing. Okay, we graphed and we found where the two lines intersected. Again, we're just now solving that by using algebra only and no graphing. All right, so I want y'all to go through and try to work these next problems. If you got any questions, please come find me and get some help. All right, I'll be more than happy to help you out.